Okay, let's take a look at what you did here and what my solution to that previous exercise was. So within the spark.zip file that you downloaded to your cluster, there are two files, lowest rated popular movie spark.py, which contains the solution to this exercise using RDDs, and also lowest rated popular movie dataframe.py that contains the Spark 2.0 data frame based version of the same problem. So let's take a look at what I did. And again, you can just edit the existing files you were working with using the Nano editor on your little Hadoop cluster thing. And all I did was insert this little thing in the middle here. So I have this ratings total and count RDD at this point of the script where I'm producing these movie ID keys reduced down to sum of ratings and total ratings. Now, before I actually boil that down to average ratings and start sorting the results, I'm going to filter out everything that had 10 or fewer items. So to do that, I create this new RDD called popular totals and count that takes ratings, totals, and count and filters them out based on this lambda function that takes in a value of x and checks whether x11 is greater than 10. So let's break that down a little bit because the syntax there is a little bit confusing. So with filter, we're passed in the entire key value pair for each row that comes in, right? So we first have to take x1. Now remember, we start counting at 0, so 1 is actually the second field. So we're saying take that input tuple and take the second piece of it. And that second piece of it is this this sum of ratings, total ratings tuple here, okay? So then, once we say x1, at this point we have this tuple, sum of ratings, total ratings. And then we can further say, I want 1 on that, the second field of that tuple. So x bracket 1 gives us this tuple, x bracket 1 bracket 1 gives us the second value within that second value. So that's how we extract the total ratings out of that mess. So we're basically saying filter it if the total ratings is greater than 10. Okay, and from that point, we can just use popular totals and count instead of ratings totals and count and keep on doing things the way we were doing it before. So let's go ahead and run that and see what kind of results we get. So again, I'll log into my little pseudo cluster. And you can see that script is already there. So all I have to do is run spark-submit lowest rated popular movie spark.py. And let's see what we get. All right. So now, this is interesting. You know, by filtering things out to things that were rated by more than 10 people, first of all, we're getting more recognizable movies. You know, they were actually watched by more than one person to begin with. And we have a little bit more statistical confidence that more than one person thought they were terrible. And it turns out the worst of the worst is Children of the Corn, The Gathering from 1996. Now remember, this data set is from 1998, I think it was, so you're not going to see new bad movies. These are all going to be older bad movies. So if you were going to be making a new Mystery Science Theater or something, this might be a good source of ideas. Indeed, I do not remember Children of the Corn, The Gathering, and like I said before, there's a good reason for that. Of all the people who watched it, the average rating was only 1.3 stars. Body Parts, also bad. Amityville 2, bad. Lawnmower Man 2, bad. RoboCop 3, should have been forgotten. Free Willy 3, should never have been made. So on and so forth. Man. So there you have it. Now let's look at the Spark 2 solution here. And for that, we're going to take a peek at the lowest rated popular movie data frame Python script that I gave you. I'm just going to look at it in a nice little editor here to make it a little bit prettier to look at. Only thing different here is, again, I've inserted a filter command at the same point. So in between getting my averages and counts, where I join together all the average ratings and counts together, I'm now going to filter out all the rows where the count was less than 10. So this is saying filter on this expression where the count column is greater than the value 10 and only give me back in popular averages and counts a data frame that contains results with a count greater than 10. And then I can just substitute that data frame in here when I'm when I'm sorting it by the average ratings and taking the top 10 and then printing them out. So that's the only difference there. You can see here already that the syntax is a lot easier to wrap your head around when you're using data sets. You can just use, very intuitive expressions like count is greater than 10 instead of trying to think about, oh, how do I extract this field out of this tuple, out of this key value pair? So there's really a lot to be said about the Spark 2 way of doing things. Let's go ahead and run this guy as well. Now remember, since I'm using Spark 2, I currently have to tell Hortonworks about that. So let's say export spark underscore major underscore version equal 2, and we will call spark-submit lowest rated popular movie data frame.py, and we should get more or less the same results. Off we go. And there we have our terrible friends again. Children of the Corn, The Gathering, Body Parts, Amityville 2, Lawnmower Man 2, Robocop 3. So, same end results here, which is kind of good to see. We learned about this two completely different ways, but we got the same answer. And I don't know about you, but I think the data frame approach is a lot easier to use. And, when you're running it at large scale, it's going to be faster as well. So there you have it. That thus concludes our Spark section of the course. Congratulations. So there you have it, an overview of Apache Spark. We actually solved a few real problems using it and gave you a little bit of a taste of its power with MLlib and machine learning. There's a whole lot more I could tell you about Spark. It's just such a huge area that you can learn more about. So again, there are other courses available that go into much more depth with Apache Spark and also teach you how to program Spark with Scala, which is really the language of choice for doing Spark development. But you know enough to be dangerous at this point, so let's move on. We're going to talk about integrating relational databases and relational database APIs with Hadoop in our next section.